welcome back to Just Another Melting Channel. That's right, I'm just one of those people on YouTube melting metal and hopefully making interesting videos to watch with it. For this video, I'm going to be showing you my attempt at casting a custom sand rammer for metal casting. And by custom, I mean I made this with my 3D pen because I need a better sand rammer than this piece of wood that I've been using that I cut off of a stool last August when I first attempted to cast. I began this project the day after I posted my previous video. It has been a slow process as I worked on getting the pattern penned out with my 3D pen and smoothened out with the wood burning tool. I didn't really feel that it would be conducive to the creative process to try to film it, even in time-lapse. I do have a couple pictures, so let's explain what I did and jump right in. To start, I used a wooden dowel as my base and penned around it to give me the handle. Then using one of my graphite molds to trace a square, I penned out the butt end and built it up layer by layer. Using my wood burning pen with the knife attachment, I cut down a piece of foam into an angle, covered it with painter's tape, and penned on top of it to make the peen end of the pattern. Then I just continued to use the pen and use the wood burning tool to try to even and smoothen everything out and attach the peen end to the rest of the handle. Now once the pattern was at a point that I felt comfortable casting with, I took it out to the garage to get it rammed up. However, I came across a problem. That problem was that I was not thinking about the size of my flask when I penned it, so of course my pattern was too long. After a few hours, I was able to put together another flask more suited to the size of the 3D penned pattern. Using the false coat method of putting together my mold, I came across my second problem. I totally spaced adding draft to my pattern, which caused the sand around it to loosen when I tried to remove it from the mold. I figured I'd forge ahead anyways, see what I did there, and see if I could clean it up after it was cast. On this first pour, my ridge was very high, and because of that I ended up starving the sprue, which allowed air to get sucked down into the mold, causing entrapped air in the casting, which leads to porosity. One of the things I picked up on during this project, as I reviewed video of each pour I did, is the inconsistency with my offset pouring basin and the ridge. If you're not familiar with the terms I'm using and what it all means, I'll put links to a couple explanatory videos by Perry over at swdweeb in the description and the end cards, where he explains the importance of the height of your ridge, why the basin should have a flat bottom and not curved, the recommended depth of the basin, as well as the placement of the basin. As far as my inconsistencies, I'll make note of them as each pour occurs so I can keep track of the mistakes that I made during this project. So on this first cast, you can see the shrinkage that occurred on the butt end of the rammer. Since that's the part that stays molten the longest, it is more prone to shrinking as it cools. Since I didn't put a feeder on this, the shrinkage that occurred was almost as bad as jumping into a cold lake. Fellas, you know what I mean. I decided to clean up the first casting so I could use it to ram up the subsequent pours. I also took the pattern itself, cut the peen end off and realigned it, more on that later, and built the butt end up a little bit more to give me some weight for ramming when it was cast. Of course, I still wasn't able to add draft to the pattern in spite of my best efforts to try, but adding more PLA to the pattern's handle while trying to do this did straighten it out a bit more, so at least the handle ended up looking better. A week later, I was able to try again and got my second mold rammed up with a feeder placed on the side of the butt end. Admittedly, I almost forgot to put the feeder on, and it wasn't until I had started melting that I had remembered. Easy fix. On this second attempt, I noticed that my offset pouring basin was not very deep, and based on what I can see in the video, it appears that the ridge is still a little too high. It doesn't look like I starved the sprue though, but that could just be the camera angle. Unfortunately, this cast did not turn out as well as I'd wanted it to, still showing shrinkage on the same area as the previous attempt. My best guess is that the feeder was too small and too far away from the rammer, and it's likely that the gate from the feeder to the rammer froze before either the feeder or the butt end, resulting in shrinkage still occurring on the butt end. In addition to that, some sand must have come loose when I closed the flask, resulting in multiple jagged spots on the casting, like you see here. For the third attempt, I made sure the offset pouring basin was opposite of the feeder so I could cut the feeder directly on top of the butt end of the pattern. My offset pouring basin also has more depth to it, and the ridge is a little lower, but as you can see, still not low enough. As always, when I think I'm doing everything right, something has to mess up. In this case, the molten aluminum deciding not to use the pouring spout of the crucible. Thanks a lot, molten aluminum. At this point of the project, I became fairly frustrated. After removing the cast from the flask, I discovered that shrinkage was still occurring on the butt end of the part. After a lot of angry adult language and several rude gestures to the part, the flask, and even my furnace, I cooled off with a quench and decided that I would try one more time, but with a much larger feeder on the butt end. One week later, I was able to get the flask rammed up again, this time with the rammer laying on its side to see if that would make it easier to remove from the mold. Here's the secret, it absolutely did not make it easier. I also used a large 1.5-inch pipe to cut my feeder in on top of the butt end of the part. Then I melted some aluminum and did another pour. It may not look like it due to the camera angle, but my offset pouring basin is much deeper than on my previous pours. But it looks like the ridge is still too dang high. Lesson learned though, right? I have to take more time to cut down that ridge and round it out a little to minimize any potential turbulence during the pour. Let's go ahead and look at each cast in order and look at the issues and imperfections. On the very first cast, the butt end was too small, the peen end was not parallel to the edge of the butt end, and the handle was somewhat crooked. While it worked for me to get all of the other pours done, it was not something I could see myself using long term. The second cast still had shrinkage because of the feeder size and the distance of the feeder from the mold, with a smaller gate than I should have used. The third cast, the feeder was on top of the butt end, but because I didn't radius the feeder where it met the part, and because it might have been too small, the shrinkage that occurred where the feeder met the butt end happened right at that meeting point. And the fourth cast was just not good. My feeder slipped over to the side of the part a little while I was ramming it up, and when I pulled the pattern from the sand, it caused the sand all over the casting to come out uneven, with major flashing issues and a lot of porosity as well. I decided to start cleaning up each of the castings, cutting off the sprue and runner, and sanding them down using both my angle grinder with a flap disc, as well as my recently acquired belt sander. Over a period of about a week while sanding these parts down, I realized that my best choice for using one of these cast sand rammers would be attempt number 3, the one with the smaller feeder on the top of the butt end. So I switched my focus to sanding and cleaning up just that particular casting and did a little bit of polishing on parts of it to make it look pretty. The cleanup process itself was very interesting. I've never owned or worked with a belt sander in the past, and I had to look up a lot of how-to videos to understand the best and safest way to use it. Because of the amount of metal dust flying around while cleaning, sanding, and polishing, I made sure to have a respirator, safety glasses, and even a face shield just to be extra cautious. And because it seems like the cool thing for melters to do on melting videos, I thought I'd weigh the pattern in castings so the difference in weight could be observed. Let's take a final look at each rammer, starting from the 3D penned pattern to the monstrosity that is the final cast part. It was a very long process, and if I had a chance to do it over again, I know what I would fix and what I would change. But this was a great learning experience, and I had a lot of fun in the never-ending process of learning to cast metal. If you would have told me a year ago that I'd be confident enough to try this, I probably would have laughed in your face and then found somewhere to sit alone and fight the feelings of being overwhelmed while just thinking about trying to do this. So, what did we learn today, kids? We learned that making a ramming tool is a long and hard process that can... Ladies and gentlemen, my wife. She'll be here till Thursday. Now that Giggle McGiggleson is out of the room, thank you for watching the video. I hope it was informative, or I hope that it was at the very least entertaining. All the terminology and casting principles that I used in this video were learned from watching swdweeb's channel, so check out his linked videos in the description and end cards. This has been How Not to Cast a Sand Ramming Tool on Just Another Melting Channel. I'll see you on the next one.